Hi students, today we will study relation and function, that is second PU part of it. First PU dalli sets, relation and function you already studied. So second PU topic noduvaga I need some information from first PU, that is like a cross product and all. So adanna ಒಂದು 2 ನಿಮಿಷ explain ಮಾಡಿಕೊಂಡು then I will go to the relation and second PU relation. Okay, first if I take this a set A is equal to say 1 2, set B is equal to say 1 3. I took set A and set B, both are non-empty sets. So cross product A cross B, read it as A cross B. The cross product is a set. Cross product is a set. Cross product is a set. Containing the elements as a ordered pair. Containing the element as a ordered pair x comma y element. ಇದೊಂದು ಸೆಟ್ಟು, ಆ ಸೆಟ್ಟಲ್ಲಿ ಎಲಿಮೆಂಟು ಆರ್ಡರ್ಡ್ ಪೇರ್ ಥರ ಇರುತ್ತೆ. ಆರ್ಡರ್ಡ್ ಪೇರ್ ಅಂದರೆ 2, ಆರ್ಡರ್ಡ್ ಟ್ರಿಪ್ಲೆಟ್ಸ್ ಅಂದರೆ 3, ಎಕ್ಸ್ ವೈ ಝೆಡ್, ಎಕ್ಸ್ ಕಾಮ ವೈ ಕಾಮ ಝೆಡ್. ಆರ್ಡರ್ಡ್ ಪೇರ್ such that x is from the first set A and y is from the second set B. This is what the basic definition of A cross B definition of A cross B. Now according to this definition, what is A cross B equal to here? First element from the first set and it is ordered pair. Elements are like ordered pair. First element from first set, second element from second set. First element from first set, second element from second. All possibilities you have to write. All possibilities, all combinations you have to write. First element from first set, second element from second set. First element from first set, second element from second set. This is ordered pair as a elements in A cross B. Now, so B cross A if I write, that is x comma y such that x is from B, first element from B and second element from E. If I write like that, first element from B 1, second element from A. First element from B 1, second element from E 2. First element from B 3, second element from A. First element from B, second element from A. This is B cross A. The ordered pairs x comma y is said to be equal to A comma B if and only if first element must be equal to first, second element must be equal to second, y equal to b. So first element must be equal to first and second element must be equal to second. This is how we can call two ordered pairs are said to be equal. Now my question is, here 1 comma 3 is there, here 3 comma 1 is there. Is these two ordered pairs are equal? No, they are not equal. If these ordered pairs are not equal, then these two sets are also not equal. So A cross B definitely is not equal to B cross E. But how many elements are there in A cross B? 1 2 3 4. How many elements are there in A cross B cross A? 1 2 3 4. That is number of elements in A cross B. They are equal to number of elements in B cross E. That means A cross B and B cross A are equivalent set but not equal sets. They are equivalent set but not equal set. Next, this is A cross B and B cross A. Regarding that, because to define the relation I need these basics. ಹಾಗಾಗಿ ಫಸ್ಟ್ ಇಯರ್ ಓದಿದ್ದು ಒಂದು ಸ್ವಲ್ಪ ಬೇಸಿಕ್ಕನ್ನು ಹೇಳ್ಕೊಂಡಿದ್ದೀನಿ. The next is relation. So ಇದನ್ನೇ ತಗೋತೀನಿ. Under the same example I will explain and then I will define what exactly the meaning of relation. So one relation I will take, say R1, that is x comma y such that x is in A, y is in B, x is equal to y. This is how the elements are related. Relation means human being relations ಇದೆ. X is a brother of y, X is a sister of y, X is a father of y, and all. But mainly we are concentrating on mathematical relation. Mathematical relation ಅಂದ್ರೆ ಏನು? Equal to, x equal to y, x is less than y, x is greater than y, x is 1 more than y, x is 2 less than y, x is divisible by y, x is multiple of y, like that. So these are called mathematical relation. We are concentrating more on mathematical relations. So x equal to y. Under this, first element I have to select from first set, second element I have to select from second set, and first element must be equal to second element. First element I will select from first set, 1. Is it equal to 1, second element? If yes, you have to write. First element I have to select from first set. Is it equal to 3? No, then 1 is not related to 3. We say 1 is not related to 3. Similarly 2. Is 2 equal to 1? No, then 2 is not related to 1. Is 2 equal to 3? No, then 2 is not related to 3. So only 1 comma 1 is the what is that element in this relation R1. So I will take one more example, say R2, that is x comma y, such that x is in A and y is in B, such that x is less than y. What is R2 stands for here? Less than. What is R1 stands for here? Equal to. R2 stands for less than. So now, which is equal to, under this relation, we have to select 2 elements such that first element should be less than second element. Can I select 1 from first element? Is 1 less than 1? No, then 1 is not related to 1. Is 1 less than 3? Yes, 1 is less than 3, so 1 is related to 3. Is 2 less than 1? No, 2 is not related to 1. Is 2 less than 3? Yes, 2 is related to 3. So 1 is related to 3 and 2 is related to 3. These are the 2 elements in R2. ಅದನ್ನು ಹೇಗೆ ಬರೆಯೋದು ಅಂತೇಳಿ ಮುಂದೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. What you mean by R1, what you mean by R2, and so on. So one more relation I will take, say R3, x comma y such that. So x belongs to A, y belongs to B, ಅಂದರೆ x ನ ಸೆಟ್ A ಇಂದ ತಗೋಬೇಕು, y ನ ಸೆಟ್ B ಇಂದ ತಗೋಬೇಕು, such that x is or y is second element is 3 more than first element. Y is second element is 3 more than first element. That is also relation only. Under this relation, which is the element 3 more than in the second set, y is in the second set, 3 more than the first set. Is 1 3 more than 1? No. 3 more than 2? No. Is 3 more than 1? No. If for example y is equal to 3 ಬರಬೇಕು ಅಂದರೆ x equal to 1 ಹಾಕಿದ್ರೆ 1 plus 3 4 ಬರುತ್ತೆ. It is not 3. So none of the element in A is related to the element in B. No element in A are related to any element in B. That means it is the empty set. Relation is a empty relation. So one more I will take R4. That's equal to x comma y such that x is in A, y is in B. X is less than or equal to y. X is less than or equal to B. I think I can take difference is odd number or less than or equal to y. 2 is less than or equal to 1. 2 is less than or equal to 3. That is difference is an integer I will take. So x comma y such that x is in A, y is in B, such that difference between x and y is an integer. Difference between x and y is an integer. X and y is an integer. Difference is an integer. Now check. Difference between 1 and 1. 1 minus 1 is 0. 0 is an integer. Yes, then 1 is related to 1. 1 and 3. What is the difference? 3 minus 1, 2. 2 is an integer. Yes, 1 is related to 3. 1 is related to 3. 2 and 1. 2 minus 1 is 1. 1 is integer. Yes, 2 is related to 1. Similarly, 2 and 3. 2 is related to 3. 2 is related to 3. Right? Right? So now after studying all these examples, I wrote R1, R2, R3, R4. Can you tell me by seeing these elements, Can you tell me the definition of the relation? The definition of the relation is the relation is a subset of A cross B. Nodi, illi baradirodu elladu are the subsets of A cross B. A cross B. For all, innu ಎಷ್ಟು ಬೇಕಾದರೂ ಬರಿಬಹುದು. Infinitely many you can write. Are these subsets of A cross B or any other element you got? A cross B ದಲ್ಲಿ ಇರೋದನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದಾದರೂ ಎಲಿಮೆಂಟ್ ಬಂದಿದೆಯಾ? ಇಲ್ಲ. That is, the relation R is a subset of A cross B. Is a subset of A cross B. Sometime we can say A and B are non-empty set. Otherwise, R also becomes an empty relation. A and B are non-empty set. Okay? If A is non-empty, B is non-empty, then A cross B is non-empty. Then all the subsets of A cross B are called the relations. Relations are the subsets of A cross B. Here, the remaining relations you already studied. Here, importantly, two relations we will study. One is empty relation. Empty relation. What do you mean by empty relation? Say, example R3 is an empty relation. Then what do you mean by empty relation? That is, no element of A is related to any element in B. No element of A is related to any element in B. That relation is called as empty relation. The relation R on A or R from A to B. R from A to B. Relation, read it as like this. Relation R from A to B. The relation R from A to B is said to be empty relation if no element of A is related to any element in B. No element of A is related to any element in B. No element in A is related to any element in B. Very importantly, we should say A and B are non-empty sets. We should say where A and B are non-empty sets. Otherwise, it is, empty relation only. Either A is an empty set or B is an empty set, then definitely A cross B is empty, hence R is empty relation. No doubt. But A is non-empty, B is non-empty, but R is no element from A is related to any element of B. Then this is empty relation. Very important. No element of A is related to any element in B, where A and B are non-empty set. That is very important. That relation is called as empty relation. Second one, universal relation. ಇಲ್ಲ ಇದೆ ನೋಡಿ. This is called universal relation. Is it equal to A cross B? ನೋಡಿ, A cross B ದಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ ಇಲ್ಲಿ ಬಂದಿದೆಯಾ? This is called universal relation. Then what is universal relation? each element of A is related to every element in B. Nodi, each element in A, 1 and 2, is it related to every element B? Is 1 related to both 1 and 3? Is 2 related to both 1 and 3? Nodi. That is, each element of A is related to every element of B, then that relation is called as universal relation. R from A to B is said to be universal relation if each element of A is related to every element in B. Every element in B. In other words, hೀಗೂ ಬರೀಬಹುದು ನೀವು or we know that what is the definition of relation? Is a subset of A cross B. Is a subset of A cross B. Is A cross B is a subset of A cross B? Yes. A cross B is a subset of A cross B. Hence, A cross B is called universal relation from A to B. Universal relation. A cross B is called universal relation. ಇಲ್ಲೂ ಹಾಗೆ ಬರಿಬೋದು. ಇಲ್ಲೂ ಎಂಪ್ಟಿ ರಿಲೇಷನ್ ಅಲ್ಲೂ ಹಾಗೆ ಬರಿಬೋದು. ಏನು ಬರಿಬೋದು? ವಿ ನೋ ದಟ್ ನಲ್ ಸೆಟ್ ಇಸ್ ಅ subset of A cross B. Hence, null set is called empty relation from A to B ಅಂತ ಬರಿಬೋದು. So, next ನಾವು relation ಹೇಳುವಾಗ generally we will say relation on A. Generally 95% of the problem we will discuss relation on A. Instead of we will saying the relation from A to B, we will say relation on A. What do you mean by relation on A? Relation on A, the relation R from A to A, that's what the meaning of on A. Relation R from A to A. That's what the meaning of relation on A. In some textbook or some reference book, they defined empty relation and universal relation by using relation on A. Relation on A also. That is, relation R from A to A is said to be empty relation if no element of A is related to any element in A, where A is non-empty. Like that also they defined. Similarly, universal relation. The relation R on A means R from A to A is said to be universal relation if A cross A is a subset of A cross B. Hence, A cross A is a relation. A cross A is called universal relation. ಹಾಗಂತನೂ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. A to B ಅಂತ ತಗೊಳ್ಳೋ ಬದಲು A to A ಅಂತನೂ ತಗೋಬಹುದು. The relation from A to A which is we pronounced as relation on A. What do you mean by relation on A? Relation from A to A. Where A is a non-empty set in both the cases. So, this is regarding the basic definition and basic concept of relation and two types of relation, that is empty relation and universal relation. The next is type of relation. In that basic two relations I explained, that is empty relation and universal relation. The next is reflexive relation. The relation R from A to A, or sometime the relation R from R to R. R andre relation, R to R andre real number to real number ante. There is relation R from R to R. R to R means real number to real number. The relation R from A to A means on A means it is A to A. Is said to be reflexive relation. Reflexive if every element in A is related to A only. That is, ಇದನ್ನು ಹೀಗೂ ಬರೀಬಹುದು. That is, A is related to A only. R stands for relation. ಅದನ್ನು ಹೀಗೂ ಬರೀಬಹುದು. A is related to A. ಹೀಗೂ ಬರೀಬಹುದು. Read it as A is related to A. A is related to A. and it should be true for all A belongs to set A. ಯಾವುದೋ ಒಂದು ಎಲಿಮೆಂಟು ಆ ಎಲಿಮೆಂಟ್ಗೆ ರಿಲೇಟ್ ಆದರೆ ಆಗೋದಿಲ್ಲ. ಎಲ್ಲ ಎಲಿಮೆಂಟು that should be related to themselves. That is, A should related to A, B is related to B, C is related to C. That's what the meaning of for all. Whatever the element you took from A, that should be related to itself. A ಇಂದ 2 ತಗೊಂಡ್ರೆ 2 should be related to 2. 3 ತಗೊಂಡ್ರೆ 3 should be related to 3 and so on. That is called reflexive relation. Next to symmetric relation. The relation R from A to A, or relation R on A, or the relation R on R, the relation R from R to R. ಹೇಗಾದರೂ ಮಾಡಿ ನೀವು ಪರವಾಗಿಲ್ಲ. is said to be symmetric relation if very important, the word if A is related to B, read it as A is related to B. A comma B belongs to R ಅಂತ ಹೇಳ್ತೀವಿ, ಬಟ್ ನಿಮ್ಗೆ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಆಗೋದಿಲ್ಲ. ಹಾಗೆ ನೀವು ಓದಿದ್ರೆ, if you read like this, A comma B belongs to R, you won't understand properly. You read like that, A is related to B, ಅದನ್ನು ಹೀಗೂ ಬರೀತಾರೆ, A is related to B ಅಂತೇಳಿ, A is related to B ಅಂತ ಹೇಗಾದರೂ ಬರಿಬೋದು. ಜನರಲ್ ಮೆಥಡು ಇದನ್ನು ನಾನು ಫಾಲೋ ಮಾಡ್ತೀನಿ. ಐ ವಿಲ್ ಫಾಲೋ ದಿಸ್ ಮೆಥಡ್. That is, A is related to B. If then B is also related to A. Then B is also related to A. If A is related to B, then B is related to A. That's very important word is if. A related to B ಆದರೆ ಮಾತ್ರ B related to A ಆಗಿರಬೇಕು. If A is not related to B, then no need to think about whether B is related to A or not. This is also must be true for all elements A comma B belongs to A, set A. ಎಷ್ಟೋ ಜನ ಹುಡುಗರು ಹೀಗೆ ಮಾಡಿಬಿಡ್ತಾರೆ, ಇದಕ್ಕೆ ಬ್ರಾಕೆಟ್ ಹಾಕ್ಬಿಡ್ತಾರೆ, A comma B belongs to A ಅಂತ. If you put the bracket, this becomes an ordered pair. Ordered pair is not in the set, it is there in the relation. So confuse ಆಗಬಾರ್ದು. ಇಲ್ಲಿ ಬರೆಯುವಾಗ ಎಲ್ಲಿ ಬ್ರಾಕೆಟ್ ಹಾಕಬೇಕು, ಎಲ್ಲಿ ಬ್ರಾಕೆಟ್ ಹಾಕಬಾರ್ದು ಅನ್ನೋದು ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. If I write A comma B belongs to A, then A is a set. If I write A comma B belongs to A, then A is a relation. ಸೊ ಹಾಗಾಗಿ ಮಾರ್ಕ್ಸ್ ಎಲ್ಲಿ ನೀವು ಕಳ್ಕೊತೀರ ಅಂದರೆ ಅಲ್ಲಿ ಕಳ್ಕೊತೀರಿ. A comma B belongs to A, that means A is a set. ಸೆಟ್ಟಲ್ಲಿರೋ ಯಾವ ಎರಡು ಎಲಿಮೆಂಟ್ ತಗೊಂಡು ಅವು ರಿಲೇಟ್ ಆದರೆ, ಇಫ್ A is related to B ಆದರೆ, there must be B is related to A. If A is not related to B, then no need to think about whether B is related to A or not. So next, transitive relation. A relation R from A to A is said to be transitive relation if very important, if A is related to B and this also very important, B is related to C, A is related to B and ಅಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಅಂತ, B is related to C, that implies A must be related to C. ನೋಡಿ, very important definition. A B ಗೆ ರಿಲೇಟ್ ಆಗಬೇಕು, B C ಗೆ ರಿಲೇಟ್ ಆದರೆ ಮಾತ್ರ A ರಿಲೇಟೆಡ್ ಟು C ಆಗಿದೆಯೋ ಇಲ್ಲೋ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. ಇನ್ ಕೇಸ್ A ಇಸ್ ರಿಲೇಟೆಡ್ ಟು B ಅಷ್ಟೇ ಇದೆ, B ಇಸ್ ರಿಲೇಟೆಡ್ ಟು C ಇಲ್ಲ, then what happens, sir? Then it is transitive. A is related to B ಬಿ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ಸಿ ಇರಲಿಲ್ಲ ಅಂತಂದರೆ ನೋ ನೀಡ್ ಟು ಥಿಂಕ್ ಅಬೌಟ್ ಎ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ಸಿ ಆರ್ ನಾಟ್, ಇಟ್ ಈಸ್ ಟ್ರಾನ್ಸಿಟಿವ್. It is transitive. If A is related to B and B is related to C, then we have to think whether A is related to C or not. If A is related to C, then it is transitive. If A is not related to C, then it is not transitive. Not transitive. So, not transitive ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಇವೆರಡು ಇರಲೇಬೇಕು. A related to B and B related to C, that implies A not related to C. ಇವಾಗ ಮಾತ್ರ we can say it is not transitive. ಸರ್ ಇದೊಂದೇ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲ. ಇಫ್ A is related to B, ಇಷ್ಟೇ ಇದೆ. B is related to C ಇಲ್ಲ, then what happens, sir? Nothing will happen. It is transitive. Then R is transitive. ಯಾವಾಗ A related to B ಇದ್ದು B related to C ಇಲ್ಲದೆ ಇದ್ರೆ it is transitive. That means all singleton sets, that means a set contain a single ordered pair, are the transitive relation. Andre the relation, if it contain a single element, then it must be transitive. No need to think about the other things. ಹೌದು ಅಲ್ಲೋ ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. ಸಿಂಗಲ್ ಎಲಿಮೆಂಟ್ ಇತ್ತು ಅಂತಾದರೆ ಆ ರಿಲೇಷನ್ನಲ್ಲಿ ಇಟ್ ಮಸ್ಟ್ ಬಿ ಟ್ರಾನ್ಸಿಟಿವ್. Next to last one, it is equivalence relation. A relation R from A to A is said to be equivalence relation if R must be reflexive, R must be symmetric, R must be transitive. Reflexive, symmetric, transitive. ಮೂರು ಆದರೆ that type of relation is called equivalence relation. So the relation is said to be equivalence relation if R is reflexive, symmetric as well as transitive. ಮೂರು ಆದರೆ ಮಾತ್ರ it is said to be equivalence relation. Now while discussing the problem, I will make two parts. One is I will discuss the problems by taking finite sets. Then I will discuss the problem by taking infinite sets. Finite sets ಗೆ ಬೇರೆ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಇನ್ಫೈನೈಟ್ ಸೆಟ್ಸ್ಗೆ ಬೇರೆ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ಪ್ರೂವ್ ದಟ್ ಇಟ್ ಈಸ್ ಅ ರಿಲೇಷನ್ ಅಂದಾಗ ಬೇರೆ ಮೆಥಡು, ಪ್ರೂವ್ ದಟ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಅ ರಿಲೇಷನ್ ಅಂತಂದಾಗ ಬೇರೆ ಮೆಥಡ್. ಟು ಡಿಸ್ಪ್ರೂವ್ ಎನಿ ಪ್ರಾಬ್ಲಮ್, ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಈಸ್ ನಾಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್ or it is not transitive or it is not symmetric, while you are disproving the problem, counter example is enough. Say it is not reflexive ಅಂತ ಹೇಳೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್, ನಾಟ್ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್, ನಾಟ್ ಟ್ರಾನ್ಸಿಟಿವ್ ಅಂತ ಹೇಳೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್. ಕೌಂಟರ್ ಎಕ್ಸಾಂಪಲ್ ಈಸ್ ಇನಫ್ ಟು ಸೇ ದಟ್ ಇಟ್ ಈಸ್ ನಾಟ್ reflexive, symmetric or transitive. But while to prove that it is reflexive or to prove that it is symmetric or to prove that it is transitive, you must have to prove for all. Illidiyala, for all. It should be prove for all the elements. For all A, B, C belongs to A, set A. ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಗೂ ಆಗಿರಬೇಕು. ಒಂದು ಎಲಿಮೆಂಟಿಗೆ ಪ್ರೂವ್ ಮಾಡಿಕೊಂಡು ಸರ್ ನಾನು ಪ್ರೂವ್ ಮಾಡಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಆಗಲ್ಲ. ಬಟ್ ಒಂದು ಎಲಿಮೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು ಟು ಡಿಸ್ಪ್ರೂವ್. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟುಬಿಟ್ಟು ಇಟ್ ಈಸ್ ನಾಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳ್ಬೋದು. 1000 ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟರು ಇಟ್ ಈಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳಿದಾಗ ಬರೋದಿಲ್ಲ. ಸೊ ವೈಲ್ ಪ್ರೂವಿಂಗ್ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ಇನ್ ಜನರಲ್. While disproving, counter example is enough. I will take a finite set, and I will show you what do you mean by only reflexive, only symmetric, only transitive, only reflexive and symmetric, only symmetric and transitive, and only reflexive and transitive and all. So you have to write some examples. In that I will show you one example in each case. So I will take one set, finite set A is equal to 1, 2, 3, 3 elements I will take. Now the relation R is defined from A to A. The R is defined from A to A. ಸೊ ನೀವು ಪ್ರಾಬ್ಲಮ್ ಬರೆಯುವಾಗ ಇದನ್ನೆಲ್ಲ ಮನಸ್ಸಿನೊಳಗೆ ಇಟ್ಕೋಬೇಕು. ಫಸ್ಟು ಸೆಟ್ ಡಿಫೈನ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ರಿಲೇಷನ್ ಡಿಫೈನ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಮೆಥಡ್ಗೆ ಹೋಗಬೇಕು. ಫಸ್ಟ್ ಐ ಡಿಫೈನ್ ದಿ ಸೆಟ್ A is equal to say 1, 2, 3. Then I define the relation R from A to A. How it is defined ಅಂತ ನಾನು ಬರೆಯೋದಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ. It is depend on the problem. First one, only reflexive ಮಾತ್ರ, ಸಿಮೆಟ್ರಿಕ್ ಆಗಬಾರ್ದು, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬಾರ್ದು, only reflexive. So can I write as say R1 relation 1 only reflexive ಆಗಬೇಕು ಅಂದರೆ ಏನೇನಿರಬೇಕು ಅಂತ ಹೇಳಿದ್ದೀನಿ. Each element should related to themselves, that is 1 must be related to 1, 2 must be related to 2, 3 must be related to 3. Of course this is the smallest reflexive relation. 1, 1, 2, 2, 3, 3. And it is smallest equivalence relation also. ಅಲ್ಲಿ ಬಂದಾಗ ನೋಡ್ಕೊಳ್ಳೋಣ equivalence relation also. Now reflexive I wrote 1, 1, 2, 2, 3, 3. 1 is related to 1, 2 is related to 2, 3 is related to 3. My question is it not transitive? Is it not symmetric? So A related to B, that is 1 related to 1. B related to A, 1 related to 1 again. So it is transitive also. It is symmetric also. ಬಟ್ ನಾವು ಕೇಳಿದ್ದೇನೋ ಓನ್ಲಿ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂದರೆ ಸಿಮೆಟ್ರಿಕ್ ಆಗಬಾರ್ದು, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬಾರ್ದು. ಸೊ ಸಿಮೆಟ್ರಿಕ್ ಆಗಬಾರ್ದು ಅಂದರೆ ನಾನು 1, 2 ಸೇರಿಸ್ತೀನಿ, ಬಟ್ 2, 1 ಸೇರಿಸಲ್ಲ. ಐ ವಿಲ್ ರೈಟ್ 1, 2, ಬಟ್ ಐ ವೋಂಟ್ ರೈಟ್ 2, 1. If 1, 2 is there, 2, 1 is not there, then it is not symmetric. Is it not transitive? We can check the elements. A related to B, B related to C, then A related to C, that is 1 related to 2. It is there, 1 related to 2 is there. So it is transitive also. So only reflexive andreno transitive ಆಗಬಾರ್ದು. Can I write 2, 3 and I won't write 1, 3? Now ಅವಾಗಲೇ ಹೇಳಿದೆ counter example is enough to say it is not transitive. So A related to B, B related to C, A related to C, 1, 3 ಇರಬೇಕಿತ್ತು, ಇಲ್ಲಿಲ್ಲ, 1, 3 ಇಲ್ಲ. Since 1, 3 is not there, it is not transitive. So it is only reflexive, neither symmetric nor transitive. So 1, 2 ಇದೆ, 2, 1 ಇಲ್ಲ, so it is symmetric ಅಲ್ಲ. 1, 2 ಇದೆ, 2, 3 ಇದೆ, 1, 3 ಇಲ್ಲ, so it is transitive ಅಲ್ಲ. Next, only symmetric. Symmetric ಮಾತ್ರ ಆಗಿರಬೇಕು, ರಿಫ್ಲೆಕ್ಸಿವ್ ಆಗಬಾರ್ದು, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬಾರ್ದು. So only symmetric. Can I write simple thing 1, 2 and 2, 1? Is it reflexive? No, because 1, 1, 2, 2, 3, 3 is not there. Is it transitive? No. A related to B, B related to C, A related to C, 1, 1 ಇರಬೇಕಿತ್ತು, ಇಲ್ಲ ಇಲ್ಲಿ. So it is not transitive. Means what? It is only symmetric. Next I will take it is only transitive, only transitive. Say I will take R3, only transitive. Can I write a singleton set 1 comma 2? Is it transitive? Yes, of course, all singleton sets are transitive. All singleton sets under the relation are transitive. Is it reflexive? No, 1 1 2 2 3 3 is not there. Is it symmetric? 1 2 is there, but 2 1 is not there, so it is not symmetric. So only transitive, singleton set bardre, that is more than enough. Next, that is only reflexive and symmetric. ಅಂದ್ರೆ ಏನರ್ಥ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಸಿಮೆಟ್ರಿಕ್ ಆಗಿರಬೇಕು, ಬಟ್ ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಿರಬಾರ್ದು. ಓನ್ಲಿ ರಿಫ್ಲೆಕ್ಸಿವ್ ಸಿಮೆಟ್ರಿಕ್ ಅಂದರೆ ಏನರ್ಥ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಸಿಮೆಟ್ರಿಕ್ ಆಗಬೇಕು, ಬಟ್ ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬಾರ್ದು. ಸೊ ಐ ವಿಲ್ ರೈಟ್ R4. ರಿಫ್ಲೆಕ್ಸಿವ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಏನು? 1 1 ಇರಬೇಕು, 2 2 ಇರಬೇಕು, 3 3 ಇರಬೇಕು, ರಿಫ್ಲೆಕ್ಸಿವ್. ಇಲ್ಲಾಂದ್ರೆ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಲ್ಲ. ದಿಸ್ ಇಸ್ ದಿ ಸ್ಮಾಲೆಸ್ಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಸೆಟ್, ಆಫ್ ಕೋರ್ಸ್, ಸ್ಮಾಲೆಸ್ಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಸೆಟ್. ಸಿಮೆಟ್ರಿಕ್ಕು ಆಗಬೇಕು. 1 2 ಇದ್ದರೆ 2 1 ಇರಲೇಬೇಕು. A related to B, B related to C, then A related to C, 1 comma 1, it is there, it is transitive also. It is there, 1 comma 1. So it is transitive also. Transitive ಆಗಬಾರ್ದು ಅಂತ ಹೇಳಿದ್ವಿ, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬಾರ್ದು. ಸೊ ಆ್ಯಡ್ ಆನ್ ದಿ ಎಲಿಮೆಂಟ್ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. 2 comma 3 ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 3 comma 2 ಆ್ಯಡ್ ಮಾಡಲೇಬೇಕು, ಇಲ್ಲ ಸಿಮೆಟ್ರಿಕ್ ಆಗಲ್ಲ. If I add 2 comma 3, you must add 3 comma 2. Otherwise, it not become symmetric. I said it should be symmetric also, reflexive as well as symmetric also. Is it transitive? Check once. Is it transitive? If A is related to B and B is related to C, then A is related to C. That is 1 comma 3 must be there in the relation. Is there 1 comma 3 is there in the relation? No. 1 comma 3 is not there in the relation. Hence, it is not transitive. Counter example is enough to disprove the theorem. One counter example is enough to say that it is not transitive. Even you can give 100 example is not enough to say it is transitive. One counter example is enough to say it is transitive. It is not transitive. So it is not transitive. Next one, only reflexive and transitive, but not symmetric. Only reflexive and transitive. I will take say R5. Reflexive ಆಗಬೇಕು ಅಂದರೆ 1 1 2 2 3 3 ಇರಲೇಬೇಕು. Yes, of course, it is transitive also, but at the same time it is symmetric also. A is related to B, so B is related to A, 1 comma 1. A is related to B, 1 2 comma 2 is related to 2, so 2 is related to 2, so it is symmetric also. Symmetric ಆಗಬಾರ್ದು ಅಂತ ಹೇಳಿದಾನೆ. So can I add 1 comma 2 and I won't add 2 comma 1? Is it transitive? First check. A related to B, B related to C, then A related to C, 1 is related to 2, it is there, 1 is related to 2. It is a transitive, but not symmetric, because 1 2 is there, 2 1 is not there. The last one, only symmetric and transitive. I will write here only, that is R6. Symmetric ಆಗಬೇಕು, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಬೇಕು, ಬಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಆಗಬಾರ್ದು. Can I say or can I write 1 comma 1? Is it symmetric? Yes, A is related to B, B is related to A. 1 is related to 1, 1 is related to 1. It is symmetric. Is it transitive? Yes, all singleton sets. The relation contain a singleton set. Is a transitive. Is it reflexive? No, because 2 comma 2 3 comma 3 is not there. Reflexive ಆಗಬೇಕು ಅಂದರೆ ಏನಿರಬೇಕು? 1 1 2 2 3 3 3 ಇರಬೇಕು, 3 ಪೇರ್ ಇರಬೇಕು. 1 1 ಇದೆ, 2 2 3 3 ಇಲ್ಲ, so it is not reflexive, but it is symmetric as well as it is transitive. So next we will discuss some general problem, then we will go for some particular problem, that is finite set, infinite set. First we will discuss on infinite set. First I will take the relation R on the set of straight lines. The relation is parallel to is an equivalence relation. The relation is parallel to is an equivalence relation. Proof. So ಇದನ್ನ ನೀವು ಪ್ರಾಪರ್ ವೇದಲ್ಲಿ ಬರೆದರೆ R is equal to say L1 comma L2 line 1 comma line 2 such that L1 is parallel to L2 L1 is parallel to L2 so and L1 comma L2 belongs to set L where L is the set of straight line. L is the set of straight line, that is L1 comma L2 such that ಹೀಗೂ ಬರೀಬಹುದು ನೀವು such that or set L1 is parallel to L2 is your relation. Now I need to prove that it is an equivalence relation. First I will take what is parallel to represented as. I will take parallel to represented as I will represent this by R. I will represent this by R. And the elements I took it as L1 and L2. L1, L2, ಇನ್ನೊಂದು ಬೇಕಾದ್ರೆ L3 are the three elements belongs to set L, a straight line. Now equivalence relation means what? It should be reflexive, it should be symmetric, it should be transitive. And while proving I clearly told you have to prove in general, that is R is reflexive. R is reflexive. Reflexive always start from we know that always start from we know that. ಏನು ನಮ್ಗೆ ಗೊತ್ತು? Is each line is parallel to itself? ಹೇಗೆ ಬರೆಯೋದು ನಾವು ಅದನ್ನು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ? We know that L1 is parallel to L1. That is each line is parallel to itself. L1 is parallel to L1. Relational symbolically ಹೆಂಗೆ ಬರೆಯೋದು ಇದು? L1 is parallel to L1. I took is parallel to as R. R stands for is parallel to. R1 stands for is parallel to. So L1 is parallel to L1. L1 is parallel to L1. Is it true for all L1 belongs to L? ಎಲ್ಲ ಲೈನಿಗೂ ಟ್ರೂ ಅದು. Is L1 is parallel to L1? What about L2? Is it parallel to itself? L3 is it parallel to itself? L4. So for all it is true. Therefore R is reflexive. Next, R is symmetric. Symmetric start from let. Take one element. Let L1 is parallel to L2. Read it as L1 is parallel to L2. L1 is parallel to L2. Write in terms of word. Is it L1 is parallel to L1, L2? L1 is parallel to L2. Is it implies? What about L2? Is it parallel to L1? Is it L2 is parallel to L1 symbolically? Is it true for all L1, L2 belongs to L? If yes, then R is symmetric. So symmetric start from let. ಏನು ತಗೋಬೇಕು? L1 is parallel to L2. So L1 is parallel to L2 implies L2 is parallel to L1. What it implies? L2 is parallel to L1. Similarly, R is transitive. R is transitive. Transitive start from let two elements. L1 is parallel to L2 and L2 is parallel to L1. ಎರಡು ಎಲಿಮೆಂಟ್ ತಗೋಬೇಕು. What is this implies? L1 comma L2 belongs to R. L1 is parallel to L2 and L2 comma L1 belongs to R means L2 is parallel to L1. What it implies? L1 is parallel to L2 and L2 is parallel to L3. Is it implies L1 is parallel to L3? It is L3, sorry. It is L3. Is it L1 is parallel to L3? Yes, L1 is parallel to L3. What it implies? L1 is parallel to L3. Read it as L1 is parallel to L3. Is it true for all L1, L2, L3 belongs to the set L? Therefore, R is transitive. Since R is reflexive, symmetric and transitive, it is an equivalence relation. Since R is reflexive, symmetric and transitive, it is an equivalence. Let A be a set of all boys students in a school. Show that the relation R in A given by R is equal to A comma B. A is a sister of B. Now ತಗೊಂಡು set ಯಾವುದು? Set of all boys students. ಅಲ್ಲಿ A is a sister of B. Is it possible? It's not possible. That is, R is an empty relation. Is empty relation a subset of that A cross A? Is it a subset of A cross A? Therefore, R is empty relation. What is the second one? Let R dash is equal to A comma B. The difference between their height A and B is less than 3 meter, not 3 centimeter. ಎರಡು ಮನುಷ್ಯನ ಮಧ್ಯ ಡಿಫರೆನ್ಸು, that is difference between the heights is less than 3 meter. ಎರಡು ಮನುಷ್ಯರ ಮಧ್ಯ ಡಿಫರೆನ್ಸ್ ಇನ್ ಹೈಟ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 3 ಮೀಟರ್ ಆಗಿ ಸಾಧ್ಯ ಇದೆಯಾ? ಇಬ್ಬರ ಮಧ್ಯೆ ಹೈಟು ಇಲ್ಲೊಬ್ಬನು ಇದ್ದಾನೆ. ದಟ್ ಡಿಫರೆನ್ಸ್ ಇನ್ ಹೈಟು ಇಟ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 3 ಮೀಟರ್. ಈಸ್ ಇಟ್ ಪಾಸಿಬಲ್? ನೋ, ಇಟ್ ಈಸ್ ಇಂಪಾಸಿಬಲ್. 3 ಮೀಟರ್ಗಿಂತ ಹೈಟ್ ಡಿಫರೆನ್ಸ್ ಸಾಧ್ಯ ಇಲ್ಲ. ಸೊ ಲೆಸ್ ದ್ಯಾನ್ 3 ಮೀಟರ್ ಅಂತ ಬಂದಾಗ ಆಲ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಈಚ್ ಸ್ಟೂಡೆಂಟ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಒನ್ ಅನದರ್. ಸೊ ಇಬ್ಬರು ಸ್ಟೂಡೆಂಟ್ ತೊಗೊಂಡಾಗ ಇನ್ ಕ್ಲಾಸಲ್ಲಿ ಅವ್ರ ಹೈಟು ಮಸ್ಟ್ ಬಿ, ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಹೈಟ್ ಮಸ್ಟ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ 3 ಮೀಟರ್. ಇಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ಟ್ರೂ. ಮೀನ್ಸ್ ವಾಟ್? R is equal to A cross A. All the students you are going to get A cross A. Is it a subset of A cross A? R dash, of course. R dash, they given R dash. Therefore, R dash is a universal set. That proves this. The next problem. Let T be a set of all triangles. ಸೆಟ್ ಆಫ್ ಆಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಅಂದರೆ ಟಿ ಏನು ತಗೋಬೇಕು ಸೆಟ್ ಆಫ್ ಆಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಟಿ ಬಿ ಎ ಸೆಟ್ ಆಫ್ ಆಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ and R is the relation congruent to. What is R stands for? Congruent to. Congruent to. The relation R stands for is congruent to. Is congruent to. R stands for congruent to. Prove that R is an equivalence relation. R is an equivalence relation. What do you mean by equivalence relation? Equivalence relation means R should be a reflexive, R should be symmetric, R should be transitive. So one by one ಮಾಡ್ಕೊಂಡು ಹೋಗೋಣ. First one, R is reflexive. What do you mean by reflexive and how we prove the reflexive relation? Reflexive relation proof always start from we know that. Always reflexive relation start from we know that. What do you know? ಏನು ಗೊತ್ತು ನಿಮಗೆ? Is T1 is congruent to T1 itself? Each triangle is congruent to itself. Did you study it in congruence chapter? Yes. So T1 is congruent to T1. ಇದನ್ನು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಬರೆಯೋದು ಹೇಗೆ? T1 R ಅಂದರೆ is congruent to, R stands for is congruent to T1. T1 is congruent to T1. Is it true for all T1 belongs to T? ಈ Tದಲ್ಲಿರೋ ಯಾವ ಎಲಿಮೆಂಟ್ ತಗೊಂಡ್ರು ಇದು ಟ್ರೂನಾ? Yes. Therefore R is reflexive. Next is R is symmetric. Symmetric start from let one element. Let ಯಾವುದು T1, T2 belongs to R. T1, T2 belongs to one element ತಗೋಬೇಕು. R ಅಲ್ಲಿರೋ one element ತಗೋಬೇಕು. What do you mean by T1, T2 belongs to R? Is it implies T1 is congruent to T2? Is it a meaning of T1, T2 belongs to R? ಓದೋದು ಹೇಗೆ ಅಂತ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. T1 is congruent to T2. T1 is congruent to T2. T1 is congruent to T2. Is it implies T2 is it congruent to T1? ಇದನ್ನು ಕೂಡ ಕಾಂಗ್ರುಯೆನ್ಸಿ ಚಾಪ್ಟರ್ ಓದಿದ್ರೆ ಕಾಂಗ್ರುಯೆಂಟ್ ಟ್ರಯಾಂಗಲ್ ಚಾಪ್ಟರ್ಲಿ if T1 is congruent to T2 then T2 is congruent to T1. Yes, it is always true. Is it implies mathematically T2 is congruent to T1? ಬರೆಯೋದು ಹೀಗೆ T2, T1 belongs to R. ಓದೋದು T2 is congruent to T1. T2 is congruent to T1. Is it true for all T1, T2 belongs to the set T? All T1, T2 belongs to set T? Yes. Therefore R is symmetric ಅಂದ್ರೇನು? If A, B belongs to R, you need to prove B, A belongs to R. So I took A, B belongs to R. I proved B, A belongs to R. Similarly, R is transitive. So transitive. How to prove transitive? ಎರಡು ಎಲಿಮೆಂಟ್ ತಗೋಬೇಕು, ಮೂರನೇ ಎಲಿಮೆಂಟ್ ಇದೆ ಅಂತ ತೋರಿಸ್ಬೇಕು. ಎಲ್ಲಿ ತಗೋಬೇಕು ಎರಡು ಎಲಿಮೆಂಟ್ನ? ರಿಲೇಷನಲ್ಲಿ ತಗೋಬೇಕು. ಟೇಕ್ ಟೂ ಎಲಿಮೆಂಟ್ಸ್ ಇನ್ ರಿಲೇಷನ್. ಲೆಟ್ ಎರಡು ಎಲಿಮೆಂಟ್ T1, T2 belongs to R and ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ T2, T3 belongs to R. ಎರಡು ಎಲಿಮೆಂಟನ್ನು ಟ್ರಯಾಂಗಲಲ್ಲಿ ತಗೋಬೇಕು. What do you mean by T1, T2 belongs to R? Is it implies T1 is congruent to T2 and is it T2 is congruent to T3? If yes, what it implies? Is it T1 is congruent to T3? Yes. Therefore T1 symbolically is related to T3. T1 is related to T3. Is it true for all T1, T2, T3 belongs to set T? ಈ ಸೆಟ್ಟಲ್ಲಿರೋ ಎಲ್ಲ ಟ್ರಯಾಂಗಲ್ಗೂ ಅಪ್ಲೈ ಆಗುತ್ತದು? Yes. Therefore R is transitive. Since R is reflexive, symmetric and transitive, it is an equivalence relation. It is an equivalence relation. So the next example, let L be a set of all lines in a plane, that is L be set yavado L. I denoted by the set by L. L is the set of all straight lines in a plane, that is L. Wherever I use the symbol L, it is understood that it is a set of all straight lines in a plane. That's what the meaning of L. Define the relation R. How R is defined? R ಹೇಗೆ define ಮಾಡಿದಾರಂತೆ? Is perpendicular to. Is perpendicular to. This is your R. R defined as is perpendicular to. R defined as is perpendicular to. Is perpendicular to. This is your R. R. One by one ಮಾಡ್ತಾ ಹೋಗೋಣ. Is R reflexive? ನೋಡೋಣ. R is not reflexive. R is not reflexive. ಸೊ ರಿಫ್ಲೆಕ್ಸಿವ್ ಆಗಬೇಕು ಅಂದರೆ ಏನಾಗಬೇಕು? ಆ ಎಲಿಮೆಂಟು ಅದೇ ಎಲಿಮೆಂಟ್ಗೆ ರಿಲೇಟ್ ಆಗಬೇಕು. ಅಂದರೆ L1 ಶುಡ್ ರಿಲೇಟೆಡ್ ಟು L1. ವಾಟ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಹಿಯರ್? ರಿಲೇಷನ್ ಡೆಫಿನೇಷನ್ ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು. ಈಸ್ L1 ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L1 ಇಟ್ ಸೆಲ್ಫ್? ನೋ. L1 is parallel to L1. L1 is parallel to L1. So reflexive relation start from we know that. What do we know? L1 is not perpendicular to L1 itself. L1 is parallel to L1. L1 is not perpendicular to L1 itself. ಅದೇ ಲೈನಿಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತಾ? ಇಲ್ಲ. That is L1 is not perpendicular to. L1 is not R ಅಂದ್ರೇನು? perpendicular to L1. L1 is not perpendicular to L1. ಇಲ್ಲಿ ಬರೆಯುವಾಗ don't write for all. Don't write. Whenever you are disproving, don't write for all. ಎಲ್ಲದಕ್ಕೂ ಆಗಬಾರ್ದು ಅಂತ ನಮಗಿಲ್ಲ, ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನಮಗೆ ಅವಶ್ಯಕತೆ ಇರೋದೇನೋ ಯಾವುದಾದ್ರು ಒಂದಕ್ಕಾಗಲಿಲ್ಲ ಅಂದರೂ ಸಾಕು. ಸೊ ಫಾರ್ L1 ಎಲ್ಲಿದೆ ಅಂತ ಬರಿಬೇಕು. L1 ಇಲ್ಲಿ ತೊಗೊಳ್ಬೇಕಾದ್ರೆ ನೀವು ರಿಲೇಷನಲ್ಲಿ ಆ L1 ಎಲ್ಲಿಂದ ತೊಗೊಂಡಿದ್ದೀರಾ? ಎಲ್ಲಿಂದ ತೊಗೊಂಡಿದ್ದೀರಾ? ಸೆಟ್ ಆಫ್ ಸ್ಟ್ರೇಟ್ ಲೈನಿಂದ ತೊಗೊಂಡಿದ್ದೀರಾ? ಅದನ್ನ ಬರಿಬೇಕಿಲ್ಲಿ. ಫಾರ್ L1 ಬಿಲಾಂಗ್ಸ್ ಟು R. Therefore R is not symmetric. Next one ಏನು ಹೇಳಿದ್ದಾರೆ? R is reflexive. That is R is not reflexive. R is not reflexive. Second, R is not symmetric. Is it not symmetric or R is asymmetric? R is asymmetric. R is symmetric. ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ನೀವು ಇವಾಗ. ಯು ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ಇಟ್ ಈಸ್ ಸಿಮೆಟ್ರಿಕ್. ಪ್ರೂಫ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ಲೆಟ್. ಎಷ್ಟು ಎಲಿಮೆಂಟು? 1 ಎಲಿಮೆಂಟು. L1 ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L1. L1 ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L1. ಓದೋದು ಹಾಗೆ, ಬರೆಯೋದು ಹೇಗೆ? L1 ಬಿಲಾಂಗ್ಸ್ ಟು R. ಬಟ್ ಓದೋದು ಹೇಗೆ? L1 ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L1. L1 ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L2. ಒಂದು ಎಲಿಮೆಂಟ್ ತಗೋಬೇಕು. ವಾಟ್ ಯು ಮೀನ್ ಬೈ ದಿಸ್ ಹೇಳೋದನ್ನು ನೆಕ್ಸ್ಟಲ್ಲಿ ಬರೀಬೇಕು. ವಾಟ್ ಯು ಮೀನ್ ಬೈ ದಿಸ್? ಈಸ್ ಇಟ್ L1 ಈಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು L2? ದಟ್ಸ್ ವಾಟ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್. L1, L2 ಬಿಲಾಂಗ್ಸ್ ಟು R. Is it meaning of this is L1 is perpendicular to L2? If L1 is perpendicular to L2, what about L2? Is it perpendicular to L1? If L1 is perpendicular to L2, ಇದು L1, ಇದು L2. If these two are perpendicular, if L1 is perpendicular to L2, what about L2? L2 is perpendicular to L1. Mathematically ಹೇಳಿ ನೋಡೋಣ. Is L2, is it perpendicular to L1? L2, is it perpendicular to L1? Is it true for all L1, L2 belongs to L? ನೋಡಿ ಡಿಫರೆನ್ಸ್. ಇಲ್ಲೇನು ಬರ್ತಿದ್ದೀನಿ, ವೈಲ್ ಡಿಸ್ಪ್ರೂವಿಂಗ್ ಏನು ಬರ್ತಿದ್ದೀನಿ, ಫಾರ್ ಸಮ್ ಲೈನ್, ಒಂದು ಲೈನ್ ಆಗಿಲ್ಲ ಅಂದರೂ ಸಾಕು ನನಗೆ. ಬಟ್ ಇಲ್ಲೇನು ಬರ್ತಿದ್ದೀನಿ, ಫಾರ್ ಆಲ್, ಪ್ರತಿಯೊಂದು ಆಗಲೇಬೇಕು. ಇಫ್ L1 is perpendicular to L2, then L2 must be perpendicular to L1. L2 must be perpendicular to L1. Therefore, R is symmetric. Is R transitive? Is R transitive? R is not transitive. R is not transitive. So transitive start from two elements, ಇರಲೇಬೇಕು. Let L1, L2 belongs to R. What do you mean by that? ಓದೋದು ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ದೀನಿ, L1 is perpendicular to L2. L1 is perpendicular to L2. ಓದೋದು ಹಾಗೆ, ಬರೆಯೋದು ಹೇಗೆ. And L2 is perpendicular to L3. ಬರೆಯೋದು ಹೇಗೆ, L2, L3 belongs to R. What do you mean by that? L1 is perpendicular to L2 and L2 is perpendicular to L3. That is, ಏನಾಗುತ್ತೆ ಇವಾಗ ಇಲ್ಲಿ, L1 is perpendicular to L2 is perpendicular to L3. Is L1 is perpendicular to L3? No, L1 is parallel to L3. ಅಂದರೆ ಏನರ್ಥ, L1 is ಹೇಳಿ, L1 is not perpendicular to L3. It is not perpendicular to L3. So L1 is not perpendicular to L3 and mathematics ಅಲ್ಲಿ ಹೇಳಿ, L1 is not perpendicular to L3. ಎಲಿಮೆಂಟ್ ಎಲ್ಲಿದೆ ಅಂತ ಬರೀಬೇಕು, ಫಾರ್ L1, L2 belongs to L. Don't write for all. Right? For L1, L2 belongs to L. Therefore, R is not transitive. So it is only symmetric, neither reflexive nor transitive.